Okay, here we go. Lesson 14, proving the Pythagorean theorem. So, here we go. First one. Oh, I gotta do the cool down first. What am I doing? Okay. So the cool down first because people love the cool downs first because these are the questions that are on the quiz. So your quiz, we're gonna go on Thanksgiving break. So we'll go on a break for a week. And then we'll come back, and I don't want to do a quiz on Monday, so Monday is going to be the graphic organizer day. So graphic organizer. And then Tuesday and Wednesday after break will be unit 3, quiz 3. And that's going to include this one. So Monday's graphic organizer day, and next week is Thanksgiving break. So here we go. Cool down, test it out. Here's the question. Is this triangle a right triangle? Explain. So to solve this one, we simply need to run the Pythagorean theorem and see if a squared plus b squared equals c squared. Because in a right triangle, a squared plus b squared will always equal c squared. So to solve this one, we simply need to run the Pythagorean theorem and see if a squared plus b squared equals c squared. Because in a right triangle, a squared plus b squared will always equal c squared. All right, so if this was a right triangle, let's assume that it is. The long side would be C, and then the legs, imagine this is an L, the sides forming the L, or the right angle, the legs, are going to be A and B. I usually like to go A for the small one, B for the second biggest one. It's always how I've kind of done it. But these are interchangeable. You could make this one B as long as you make this one A. But the longest side is always C. Now, there's also a definition that you need to know, and that word is hypotenuse. So there's a word called hypotenuse, which represents the longest side in a right triangle. And it's also known as C in Pythagorean theorem. So you need to know this word. So this is a key term. The definition of the hypotenuse. It's the longest side in any right triangle. And it's also known as C in Pythagorean theorem. What is Pythagorean theorem? It's a squared plus b squared equals c squared. All right, so here we go. If this is a right triangle, then a squared plus b squared must equal c squared. Okay, this is Pythagorean theorem. This is another key term that you need to know. Pythagorean theorem. Okay, so we're just going to run it. So if this is a right triangle, then 10 squared plus 25 squared must equal 26 squared. Now, I'm going to get a calculator because I want to lead by example and teach you not to try to do these in your head. I know you know 10 squared is 100, but let's get a calculator. So, this is how you do it. This is the same on all the calculators. There's a little x squared button. So we're going to use this button a lot. And here we go. 10 squared, enter. So 10 squared is 100. 25, hit the x2 button, enter. And 26, x2 button, enter. 676. All right, so we got our hypothetical equation. So 10 squared plus 25 squared should equal 26 squared if this is a right triangle. So what's 100 plus 625? Well, that's 725. Does 725 equal 676? No. Therefore, this is not a right triangle. And if you need a because a squared plus b squared does not equal c squared. That's it. All right, hopefully this will be the first collaboration. I've got a gifted and talented artist in period 6, so please add artwork, drawings, special request to that artist. I need the Batman logo, and I need a drawing of how it's dilated. If you could do that, that'd be awesome. Anyway, we're going to try to use my math work with a gifted and talented student artist, and we're going to add some life to these cooldowns. So anyway, that's my idea. Hopefully it works out. All right. Okie doke, here we go. Lesson 14, proving the Pythagorean theorem. Let's prove it. But first, we're going to do a notice and wonder. So I'm going to make a list while you take a look at this figure. Notice and wonder. And I want you to write down at least 3 noticings and 3 wonderings. And I'm just going to try to imagine I was in your shoes and I don't know the answers, but look at this figure. You got a big triangle, and you've got the smaller triangle, and then you got like a medium-sized triangle. So for that, I'm gonna say I notice 3 triangles. That's important. I also notice 3 right triangles because I know that a straight line is 180 degrees. This means 90 degrees right here. So then this one is also 90 degrees right here. So I noticed 3 right triangles. I noticed that C equals x plus y. I noticed that. What else do I notice? Well, I noticed that this angle is shared by the big triangle, and they both have the 90 in common. So I know that the small triangle is similar to the big one. So I know that this triangle right here, side lengths X, H, and A, and we could even like shade it in a little bit. I know it's similar to the big one because they have the 90 plus they share this angle. And then secondly, I know this medium-sized triangle is also similar to the bigger one because they share this angle. So there's one in common, and then they also have the 90. So I also know that all three triangles are similar because of the angle similarity theorem. So that's really important, which means that then this will be the one, because in similar triangles they all have the same corresponding angles, and that would make this one too. Okay, so wonderings. I wonder how we prove Pythagorean theorem. How do we prove it? Like, I know how to use it based on the cooldown, but how do we prove it? I wonder how would you set up ratios to help us? And then, assuming I don't know how to prove the Pythagorean theorem, I wonder how did Pythagoras, I've heard of that guy, how did Pythagoras prove his theorem? Because it's the Pythagorean theorem, so how did Pythagoras prove it? That's what I wonder. All right, so that's the first one, notice and wonder. Your noticings and wonderings don't have to be my exact ones, but anyway, that's what I'm going with. All right, next one. I'm gonna switch gears a little bit because Pythagoras. Hold that thought one sec. Should I erase this so we have a clean slate? Okay, so I want to go to 14.3 first, which is on page 101. And I'll tell you why. I think this is the easiest way to prove that a squared plus b squared equals c squared. I think this is the easiest way. That's my opinion. So let's read the directions. When Pythagoras, this guy is an ancient mathematician, philosopher. I watched a video one time. He was credited with an early discovery of music. I guess he noticed like the pace of like the hammers. Like I think he was listening to people like build stuff. Anyway, he noticed like there was a rhythm to the hammers, and he like associated that with I think early like percussion, if I remember correctly. But anyway, he's one of the early people who associated like the pace of hammers with like a drum beat. It's pretty cool. But anyway, I want to talk about some things. So you've got two squares here. Now, with squares, your area formula for a square is just the side times the side, right? Because you got a side times the side. That gives you the area. So A stands for area in this case. So you just multiply the length of this side times the length of that side. So in both squares, so you got 1 here, 2 here, so 2 squares. This side is A and B. This side is A and B. This side is A and B, and so is this. So in both squares, the sides equal A plus B. So the area for both squares will equal A plus B times A plus B, right? A plus B times A plus B. That'll be the whole area of this square. This one will be A plus B times A plus B, the whole entire area. So the areas will be the same. So that's the first thing we need to know, is that the areas of both squares are going to be the same. So you'll see A is a little bit shorter than B. Here's A. B is a little bit longer. So here's what we're going to do. We're going to dissect these squares. So first thing that you may notice is these reddish orange triangles. Now they both have A and B. A and B. For the side lengths. So you know that this one has 1, 2, 3, and 4 red triangles. This one also has 1, 2, 3, and 4. So both squares have 4 triangles, which we're going to name 4T. We're going to call that 4T. 1, 2, 3, 4, 1, 2, 3, 4. 4 triangles, 4T. Okay, now this one, the sides are B. So you see this like orange, yellowish square? The side lengths are B on that. So your area is B squared. B times B. Now these are A and A. So A and A for sides. So the area of this one is A squared, the green one. So we can rewrite this whole area as A squared plus B squared plus the 4 triangles, which we're calling 4T. Okay, now we're going to be able to set that equal to whatever the sum of these are, or this square is. So whatever the sum of all these 5 parts are, you got 1, 2, 3, 4 triangles plus this blue square. This is going to equal the sum of these parts because we already determined that the areas are going to be the same. That means the sum of the individual parts will also be the same. So here we go. This side is going to be called C because that's the hypotenuse of a right triangle. Remember? C, longest side of a right triangle. So this blue square will have an area of C times C, which is C squared. So blue square area is C squared. So you're going to say C squared plus, and then again you've got 1, 2, 3, 4 triangles, right? Plus 4T. So now you got A squared plus B squared plus 4T equals C squared plus 4T. Now I'm trying to get these together, so what do? Well, you just subtract 4T to both sides. Because what will happen is that's out of here, and that's out of here, because 4t minus 4t, aka 4 triangles minus 4 triangles, will equal 0. So then you get a squared plus b squared equals c squared. And that's how Pythagoras solved it way back in the day. This is how the genius Pythagoras discovered his theorem. A theorem is set in stone, like it's never going to change. You can spend your entire life trying to disprove a theorem. It's not going to happen. Don't waste your time. But this whole problem is how Pythagoras discovered his theorem. And this is one of the most famous mathematicians of all time. I would say this is the biggest theorem in geometry, most widely used. Okay, cool. Let's go to 14.2. It's a little bit different. I'm gonna just like kind of get rid of this because like I don't really like it. So I want to do a different way to prove it. So same deal as before. These triangles are all similar by angle triangle similarity theorem, which we just showed you in that first problem. So what we got to do is I want to redraw these triangles. So you're going to have the small one over here. With the, we're going to say with the one side right here, the right angle here, and then the 2 down here. Let's just look at this. A is right here, the longest side, across from the 90. X is your short side, and H is your bigger side, right? This triangle, just redrawn over here. The other thing I need you to notice, and it's really important, is C equals X plus Y. C equals X plus Y. So you got another triangle here. It's like the medium-sized triangle. So let's make it a little bit bigger so that we know which one we're talking about. This is your medium-sized triangle. Yeah. Do you need this? Oh, okay. So your medium-sized triangle, you got your right angle here. H is now your small side. Y is your longer leg, not the longest. And then B is the longest. There's B. And we're gonna have our 1 here and our 2 over here. So like, yeah, B and Y, there's your 2. Okay, and then the last but not least is the big triangle. So I'm just gonna redraw that over here. This is your big triangle, biggest one. This is the big one, which you have the 1 up here, the 2 down here. So it's going to be A, B, and C. All right, so now I want to work down here a bit. And what we're going to do is we're going to compare. Now we've already shown that 1, 2, and 3, these are all similar. So triangle 1 is similar to triangle 2, which is similar to triangle 3. So they're all similar, right? So in similar triangles, the ratios of the corresponding sides are the same. So the ratios of the corresponding sides are the same. It's pretty cool. So what we're going to do is we're going to compare A to C. That's the first thing we're going to do. A over C. That's the long side and the long side. Small one and the big one. Now I see another a over here. So we're going to compare x to a. So it'll equal x over a. And remember, you can just match up the corresponding sides. The ratios will be the same. So what we're going to get,
Good morning,
in
Pumas.
the cross multiply,
Happy Friday.
a
We'd like
squared
for you to please
equals
check
c
your Infinite Campus
x.
schedules to make sure that you know which classes you're going to this morning. We'll be going over the schedule, but
Let's
just
look at b.
know that we have period 5,
b
a break, period 2,
over
4,
C
6, no advisory, no tutorial today,
will
with
equal
a dismissal time of
y
3:10.
over b.
So please check your Infinite Campus
Over
account
B.
so that you know which classes you're going to today. Have a great day on purpose.
Okay, short announcements, nice. B times b is b squared. C times y is cy. So you get a squared equals cx, b squared equals cy. So now, the next thing you gotta do is just add the left sides. So we're gonna say a squared plus b squared will equal, and then add the right sides, cx plus cy. Then, these both have a c, so you can pull out a c. So a squared plus b squared will equal c times x plus y. Remember, c also equals x plus y, right? Because c is made up of x and y. So then you can just say a squared plus b squared equals c times c. You're almost there. Final step, a squared plus b squared equals c squared. You are done. This is the other way to prove it. And there you go. Lesson 14, proving the Pythagorean theorem. Nice job. Keep it up.